Hello, my name is Patrick Flanagan, and I'll be briefing the MyPython Buddy application, which is a SWENG Capstone project. This consists of Demo 2 and Part 1. Now we're going to go over to the application context. We're going to briefly talk about the ConOps. We're going to include the mission statement, scope of the system, target audience, and features envisioned for the product. The goal of MyPython Buddy is to deliver as a minimally viable product a security assistant that helps users analyze their Python code to understand the underlying issues with the code and have the user generate a guided series of remediation pathways with the minimal amount of friction between the developer and the user interface. The application is an embedded go-between for the average coder and DevSecOps professionals. Presently, in my industry, there is an extensive code review pipelines that are out of scope and reach. This application will serve as the foundation for seamless code ingestion, automated analysis, presented an intuitive interface, and the enabling of clear and actionable insights per the integrated chatbot, all of which are modular and upgradable for future endeavors. The scope of the system. This MVP scope includes the entire set of features required for the upload operations of Python files, which are one at a time, the selection of one or more analyzers, and the respective run of each analyzer, and an asynchronous workflow with monitoring capability via an intuitive interface. The storing of each analyzer results in the intuitive model structure and the presentation of each analyzer findings in an organized view that allows for navigation of results. And with the assistance of a chatbot, perform the follow-up code and or search queries through an embedded search query and summarizer. Although the scope covers back-end workflows, analysis engines, object relational models, and user-facing components while excluding any external services that are not integrated into the defined environment. The target audience of this MVP will serve as the other party providing a pair buddy programmer assistant to Python developers. All levels of programmers will have their own set of questions, then this MVP provides the foundational fine-tuned LLM capable of answering basic coding and search query summarization questions on top of the integrated SCA toolset. The features envisioned for this product. An amenable interface with basic authentication enabled for regular and super user levels of interaction. A fine-tuned LLM quantized as a GGUF, which allows for faster processing of code and search-related questions that the user developer has for their code. An amenable chatbot interface that allows for seamless access to the fine-tuned LLM capability. A set of static code analyzers that will enable a developer to better secure their Python code. Organized results page where the user and developer can quickly sort by severity, rule, ID, message, line, and column. And finally, an integrated development environment like code review section, just kind of color coded. We're not actually diving into the full code workflow, where each result row and the findings is directly hot linked to its respective line and column numbers. Our accomplishments for sprints 3 and 4. So what we're going to talk about is the work across all the sprints, and we're going to summarize what was accomplished during the current sprint, which we have as 4. So we have user story 9, front-end artifact rendering, user story 11, automated testing, user story 12, LLM fine-tuning and evaluation, user story 13, LLM conversion and validation, user story 14, LLM archiving, user story 15, quantized LLM integration with Django API. So for sprints 3, I'm going to summarize this page. The tasking orients around the fine-tuning notebook. So we have our environment setup, installation of packages, setting up of our trainer, setting up of the settings for the quantized low-rank adapters, and the saving of related artifacts into Google Drive so that we can download and test what we got. During the scope of testing, which bled into Sprint 4, we accomplished the model acceptance testing for the merged model as compared to the GGUF model. As a result, we're going to report on testing results of those later in the presentation. And then with all of our sprints, we had a testing and documentation phase. Now with Sprint 4, It could be said in one word, integration. We integrated the LLM into our application via chatbot with the two pathways of coding and search capability. Now, what this serves as, once you have your SEA toolset run, you will have per each page a chatbot that is the foundation for questioning against the current analyzer that you ran. The baseline capability is that the chatbot is labeled, but what you're working with is all the same underneath due to challenges presented in regards to maintaining a chat history and LLM hallucination and kind of losing its way. So the gist of Sprint 4, we have integration and front end alignment towards getting a chatbot geared per each analyzer results page. And finally, again, we had testing and documentation for this sprint. Software architecture. We're going to go over our quality attributes, non-functional requirements, the rationale, and technologies chosen. So briefly, I'm going to go over all of the quality attributes. We have maintainability, performance, reliability, reproducibility, security, and usability. Now, with maintainability, we have it that each SEA tool is modularized and it kind of has a step for integration, which would need to be briefed to the developer. That was geared towards one DoD system I worked on where we can just drag and drop folders. We're not there yet, but for an MVP moving into production, we can further tune it so that we can eventually plug and play each SEA tool. We can plug and play our GGUFs with the slight adjustment to the two prompts of the search and the search and summarization. We can plug and play additional search APIs with a little bit of tooling. We can plug and play our GGUFs. We can plug and play the ability to train the base model and the input data as it fits towards the chat LLM fine-tuning. We also have our testing and fine-tuning notebooks so that you can plug and play different parameters, different endpoints for saving, and different methods of hashing and checking our artifacts. Moving on to performance, the quantization of the merged model into GGUF proved very useful, as we will see later in this presentation, the performance between the original fine-tuned merged model and the quantized one. Performance was also bolstered by using Django channels instead of having a single synchronous workflow. We're now able to upload and run asynchronously and together all the SEA tools at once. Reliability, we have introduced error handling throughout the entire application, and we have a health dashboard in which we can see what is going wrong where. Reproducibility, we have the model acceptance test series so that we can tune what we're throwing at the LLM, and we can adjust parameters to either make it ID impotent or make it a little bit creative as long as we're trying to get towards the correct answer. Reproducibility, as the creativity knobs are turned towards the more creative side, will become more probabilistic, the goal of which is to have creativity allow for still correct answers. For example, if you need a secure replacement towards MD5, there are a range of answers. Once you get down to the API level for generating code, there are still some correct answers, but we narrow that down. So the reproducibility is up to the developer handed off. The security, we have MIME type filtering so that we only upload a single Python file and that we limit it towards the size, which also can be tunable. Security also branches into HTTPS enabled via Uvacorn over Gunicorn with self-signed certificates that can be expanded in a production environment. Usability, we attempted to make a single intuitive user interface. The basis of this project is to make it so that a coder is immediately presented with their SCA toolset findings where they can immediately question and begin their work, as opposed, and this is the very basis for this project, the rationale behind this project, which I'll go into later, is that we push as far left as possible the scanning of the code to include development, where we have pre-commit checks, and that is on the developer side. That is developed against this project, and then the project itself, which if you adapt this workflow and improve upon it, you will code and be able to adjust immediately, instead of what's happened to me in industry, where you work on integrating into a technology only to be confronted with an entire code review pipeline that is enforced, where you have a due date where they'll archive your code, thus breaking your system. All right, moving forward. We're going over the rationale. Let me get to my notes for rationale. Very quickly to summarize, to go into detail, when the user of this system, which is the developer of a certain Python code set, is handed this application, they are pushed farther left in the security process. Usually you develop, you make it work, you make your client happy with an MVP. Or what they define as an MVP, sometimes MVPs are not even defined as saying, I like this is good enough. A lot of the industry works off verbal, which is very dangerous. Now, your industry, or in my sector, the government sector, you begin the process of code review, which is sometimes exposed to you at the very last minute. And they will not let you deploy even a prototype if you don't go through it. So the rationale behind this is to get security as far left to the spectrum as possible, to put it in just blunt terms. The technology is chosen. As we go over the software architecture, I'll be going over the technologies chosen. We have a developer local pathway, a developer AWS pathway. The local developer has their computer connected to GitHub and Colab, where they can run their notebooks and store their code. Moving on to AWS, within a single VPC, single availability zone, covered by security groups for SSH and our custom port to run Uvicorn. You have a prefix list for the developer and the actual users testing the application. The user connects to the computer and they connect directly to AWS. We'll be going over the components shortly. So within the system context diagram, pause for 1 second. Okay. What we're going to be going over is the technologies chosen. We have our Django web framework. We have SQLite. We have Ubuntu, which is the academic OS of which I base all my applications prior to moving to Red Hat Enterprise Linux. Ubuntu is easy to work with. AWS, to me, easier to work with to get an MVP online. SQLite, a lightweight database. Django is the basis of which I can have an authentication authorization mechanism hosting a web page where I can immediately begin work based on model and the model, I think the MCP workflow, which is kind of like model view controller, which we have a model control. I forgot the other acronym. Excuse me. We have the workflow where you can get up and running quickly. Apologize, I couldn't complete that acronym. We have our security through Uvicorn, where we have web sockets and Django channels. The model pathway, where we have original merged model, our GGUF format, and the integration of Llama CPP Python. All these technologies chosen so that the developer can get to their static tools, can get to the LLM within a minimally viable product quickly, is the reason why all of these were chosen. And as a novice on all these pathways, except for DevOps, and my profession is mostly Java and backend Python, I found that this MVP can be a baseline to get improved upon so that the security left of the application for the user that is a coder at their job will be able to get to what they need to correct their code so they can keep it prototyped in the respective industry agency's application. It will just need to be tuned towards that said industry or government application's code review process. Now, going back, let's see here. Oh, no, that concludes section 1. Hello, this is part 2 of the MyPython Buddy Demo 2 brief. Get to my notes here. The application features. We're going to be going over the use cases to prove that they are fully developed, integrated, tested, and available in the current application, and the reasons why it was not possible to accomplish the remaining work. First, let's go over what we did not do. We had user story 8, which was LLM aggregation of advice. And as a part of recent events at my work, I wanted to do a chatbot. The chatbot was consistent with a quantized LLM so that we could quickly get to a coding and search pathway from a Brave Search API. Thus, we would not do automatic LLM advice generation. Also, I got a little too deep without opening my eyes and doing kind of explicit due diligence. I got too excited that this was going to be my chance to work on machine learning, and that an LLM that is, let's call it the equivalent, if you have a DevSecOps background, of a STIG image. Again, I'm bad with acronyms, but there is the ability to run, let's say, a containerized application, and then there's the ability to run it where it's government approved or industry approved secure-wise. I do not have the ability to put that through as an LLM, and I think I would need a degree in a Capstone just for that. Quite a lot of work needs to go into that. Now, I wanted to recover where we were at so far. We're doing chatbots integrated with the ability to be the central hub of all activities for a project. I thought this was a perfect idea to do that. Now, that's the reason why we did not do 8. Number 10, API endpoint. We did have a lot of API work that went into the application. However, we do not have an external one. It was just a bridge too far, and with time constraints, we canceled it. If this was going to move to production, we probably will have an API for automated, because a lot of stuff like the government runs off of. You have an application that does something neat. Can I automate it? Do I just need to set it back in with a bunch of workers, and can I do stuff, and can you make it faster? That happens as you transition projects, from what I found. All right, so the work actually accomplished. We have user story 9, which is front-end artifact rendering, user story 11, automated testing, user story 12, LLM fine-tuning and evaluation, user story 13, LLM conversion and validation, user story 11, LLM archiving, user story 15, quantized LLM integration with the Django API. We got all these into a baseline project where user uploads their file, conducts the SCA toolset run, then goes to respective view results, and has access to a chat LLM that follows them, that's minimized to begin with, and has 2 pathways, coding and search. That baseline is done. Is it sufficient for production? I would say no. Is it sufficient to show what this thing is capable of? And then you get some 10-pound brains, and then you can really start getting maybe even separate LLM training pathways for that. We're ready to start that, and it will be continued past this capstone. That is what was accomplished. Now we're going to go over the test report, and then later a demonstration of the algorithm itself to show the user stories accomplished. So, testing report. I am going to bring this over, and I apologize. I was looking at my notes and I left it on demo 2. So the testing report. What we did is multifaceted. We had 83 unit tests between system test, which basically automates the test of the health dashboard background, and the unit test series themselves, covering a plethora of our user tests for all of our current requirements, save the ones we did not start, which was 8 and 10. So with the testing of the LLM itself, we have a model acceptance test series. We have the merged, which is MAT 12 series, and then the LLM MAT 13 series. We had similar performance across the level 1, level 2, which is the MAT XX 0102. Those are the level 1, level 2. Level 3 is the 03 attached to the MAT series, where we did search query testing and we manually evaluated how close those come. That is probabilistic, and what it is not, it's qualitative. To have it automated would be to zero out the creativity level for ID impotent results. However, that misses the point in that there are more than one pathways to getting something correct, coding and search wise. And also, the ground is constantly shifting from under you in regards to the search capability for what you're looking for, what's available, if the website shows up, if the website reads, and if the website has been edited. So, what else did we focus on? I thought I was not using the GPU correctly, and it led it down to a rabbit hole, which led to these results being reported in Sprint 4, not Sprint 3. But my intuition was correct, and I took too long to report something, so my bust there. But what I found was that I actually was using the LLM via the GPU because it was printing CUDA 0, and I saw the GPU spin up. The merged model took 90 to 110 seconds between its associated tests, the 12 series. The 13 series, we were sub-second, except for the search, but that is the time running on that was the search and the summarization. So what we're looking at is, I would say a 90 to 100, close to, let's say 50 to 90 times faster to when we quantized our LLM. So it was quite a big difference to go down to almost 100 seconds down to just a couple seconds. Scroll down a little bit farther. I printed off manually the full verbose testing of all 83 tests and put that on this sheet. That is accompanied by a 99%. Let me zoom in here. I know it looks like 188, but it's not. A 99% code coverage for 2,205 lines. We missed 29. It was diminishing returns as we just kept pushing forward, and I found that there were just some pathways, and I actually deleted some stuff like off SEMGRAPH. We didn't do Django or Flask. So I deleted those lines to up the code coverage because we just didn't have the testing, and we can always add that back in. Because when you move to production, it's like, how'd you use SEMGRAPH? Did you cover these files? I can immediately see the pathways to, well, we're going to cover these pathways, and this is how we're going to work on that. So the work can expand back from there. But there wasn't enough functionality missed where I thought, hey, this thing is going to break. And also with all my user acceptance tests, of which the UAT series and the ST01-XX series all have YouTube videos backing me walking through that. We either had automated or we had manual complete walkthrough. There was no in between due to my ignorance in Selenium and Playwright, of which I plan on covering down on that post this degree. Now, this is not going to work properly during this presentation because in the creationist document, I move stuff around. Thus, what you see is not what's actually going to turn in because there will be 2 test report documents. I am going to click on some things though. So within this automated table of contents, and then I'm going to scroll down a little bit, past the first page, each of these markdowns are automatically generated. I found it was easier to code up a solution and implement it instead of manually updating every single one of these. Because if I miss some stuff, and I actually did update every single test case in the traceability matrix in regards to formatting, in regards to getting my videos added, getting results, like the MAT series have the notebook pathway where it actually has the text files in addition to in this document. So what is automatically generated here is a GitHub page saying, boom, here is your, here is the markdown of the test specification. I'm going to scroll back down here. Every test case specification is embedded in the code itself, because the one I found is that when you commit a code repository, you immediately start having a drift, and the documentation is never married up with there. Even though you deliver it to the client, it always decides to find its way somewhere else. So it's a give or take. Covering down on that, I found that was the best thing to do. Now I'm going to click on one of these images, and it's probably going to go to the wrong place. I'm going to click on the second one. And the point of this is that we're going to have the bookmarks immediately go to the image. When I have the 2 separated test reports, this is going to be fixed. So just to let you know that this entire thing, including the traceability matrix, is an auto-generated artifact where we have our places, and they have the markdowns hot linked. just in case you want to see it locally only or you want to see it on there. Okay, so take off the test report. For the algorithm component, this will be cut off and have a video interject right in. I'm going to demonstrate the following. I'm going to upload a file, or I'm going to log in to my application. I'm going to upload the file. I'm going to perform an analysis on it, and then I'm going to walk through the usage of the coding and search query capability. That ends part 2 prior to the algorithm component part of my presentation. All right. This has to do with our demonstration of our algorithm component. So let me get my presentation here. I'm sorry, I'm not going to maximize anything, but let's see here. Description of algorithm component and the user stories associated with the algorithm component and its implementation. Okay, so here's what we're going to do. I've set up my server. We're going to go ahead and go Firefox, and we're going to accept the risk and continue. Give that a second. I'm going to highlight my password, which will be non-existent by the time you see this. Copy. I'll get rid of that equal sign. Let's do super user. This is the first time logging in. So we're going to be prompted, old password, get rid of that. Go to this. Do this. All right. Now we're in. Let's see here. Upload, browse. We're going to go to, let's see here. Where's our sample files? We're going to go to Bandit Ringer test, upload, analyze. We've already covered through the previous user stories the current process that we're going in right now. I'm going to let everything run. SEMGREP will take an extra couple of seconds. User stories we're going to go through are user story 15, user stories 9, front-end artifact rendering, 11, which is unit testing, automated testing, and then the user stories 12, 13, and 14 have specifically to do with the training, evaluation, and publishing of the finely tuned LLM. That in and of itself would take 7 hours, 6 to 7 hours to do. So that is going to be a part of the attached user documentation and other documentation associated with this. So what we're going to test is the ability to look at our results. We have our floating, we have here our floating icon that kind of follows us. It pops up as to do with the current analyzer. This leaves it open to functionality so that you can do Bandit associated things, you can do SEMGREP associated things, but for right now, we're kind of connected all to one underlying functionality that we're going to test. So let's go back to Bandit. We open up our coding window, and we are going to do the search query first. So consider so for looking at the first and only low, B404, consider possible security implications associated with the sub-process module. What are some of the security implications of the Python sub-process module? I spelled that correctly? Okay. So we're processing, and in more advanced functionality, we probably could walk through all the steps that it's going through, but this is an MVP, not production. And so what we're going to go through is, okay, so the Python subprocess module provides a way to execute shell commands from within Python. However, it's important that you are aware of the potential security implications when using this measures. You need to sanitize input or avoiding the use of untrusted environments when possible. The main issue is that you don't want the command execution to have direct access to the operating system. You want to avoid the use of shell equals true. And it goes on to describe kind of a summary of what's going on. You have sources, and there is a bit of processing from start to finish on this. So for the sourcing, we have the URL, we have a description for each one, and sometimes there is HTML present, which interferes with this, so that would have to be something that is worked with. There's so many different things with the HTML pages that this thing parses through, it kind of gets ridiculous. But the overall goal of the search functionality is to quickly get you follow-up on the processing as it pertains to, let's say, using this. So let's see here. We just did sub-process. Now let's do a little bit of a code snippet. We're going to look at this call to request without timeout. It's kind of this is, I would consider, kind of a severe softball. So we're going to say use the code word code, and there's a lot of other ways you can do this. How will, let's see here, implement, we're not going to ask a question, implement the requests module with a timeout argument. So it's pretty simple, import requests, and we get that. This response, this is meant for really very short Python requests. So we're going to put code, and I've seen a person with a PhD ask this question. It comes and goes. Not to say anything with PhDs and some stuff. You guys are so up there in the stratosphere in terms of what you're trying to do. Sometimes things elude you. So instead of going to any vlog, I'm gonna put reverse and reverse a list, and then boom. Okay, and then we can do code like reverse. Actually, I think I can go to, let's see here, a couple of my questions here, because we do have a couple of minutes, but I don't want to milk this too hard. Let's go to documentation. Let's go to test. Let's go to acceptance. Let's go to 1301. And let's see here. We got lengths of stuff, even numbers, concatenating two strings, check if a dictionary exists, swap two variables without the third in Python. I got to check and see if that was the one actually that broke. So let's just do, I hope this works. Why can't I copy? I'm going to go back to this. It actually makes it where I can copy it. I'm going to ask a couple of questions, so we'll see what happens live. So, all right. So we have how to remove duplicates. This is a set. Sometimes when I was looking at this, it might count as a failure, but one of the things I got to keep in mind is you grade exactly what you asked. So duplicates from a list, it didn't say anything about keeping order. So I got to be very careful on how I was working with this. Let's see here. Let's do another one. And this is just showing very basic capabilities. I'll do a level 2 before I stop. Actually, let's do a level 2 now because we can't just sit here forever. Let's do, oh, okay, I know this one was something that could work. There we go. Let's see here. Okay, and that handles lower and uppercase. I'm going to stop there because this can be where, like the Apollo Theater, where you line up and you throw lettuce at Patrick. There is quite a lot that could be done with this. You could even make it where it has a start and stop and actually reprograms it. Could be an actual IDE environment where you could write to this. But the goal of this project was to make it where you go in, you see your analyzer results, and then you within that, you can ask questions against that to begin the process of making the next step of securing your code. So with Bandit, we have security findings, MyPy, type checking, semgrep, it's custom rules that could supplement Bandit. Dodgy is a secrets detector. It is very dated, but it is still a detector. And then we have Vulture. Asking things upon Vulture, but like, why would I want to reduce code, or otherwise kind of wasn't crossing my mind, but getting rid of unused code would definitely help, especially as we're getting into the part where LLMs are going to be generating stuff. I don't know if it's going to generate completely what you need. Kind of an unknown frontier that we're going to need to explore. So with this, we got a one-stop shop of we upload our stuff, we check against it, and then we begin the journey of correcting our code and pushing the stuff to the left as far as possible to the process. We might even be able to make this not, I'm going to say we being a future team and possibly myself, where you integrate an IDE and you can develop at the end of every day. You can make like the last hour of your day, you're going to look at your code through this lens, and you could possibly have an IDE integrated with this to say, hey, I haven't corrected these, and then the security is pretty much right at your doorstep. So one thing I'm also going to check on here is, since I'm a super user, let's give this a second. I'm clicking on the health dashboard. All right, so the health status of my Python buddy, this has to do with system test 1, where the user test, anyway, you've seen this. We have kind of everything online. You can print, hey, your environment, your build, the application. We're still at 001. I'm not a person that's very fluent in semantic versioning. I am the one to enforce it as a DevSecOps analyst, because that's how I build my containers. But this is just a one-stop shop to say, hey, application, metadata, you got your dependencies, could be Redis, could be different parts in AWS, which we're in right now. And then underlying CPU, the NVIDIA A10G was the equivalent kind of to the 3090, except it's on the cloud. I have seen it where this thing randomly goes up and down, which is weird. Instead of being 24, it's 22 or 23. Our run times and the inference in and of itself. And we could even have it where there could be radio buttons on here. There could be combo boxes to say, all right, as an admin, and we're going to look at the admin stuff real quick to walk through this. So we're looking at our submitted files. I can delete a submitted file. I can't change anything about it. I'm not going to delete that just yet. We can look at our chat sessions, like we did some code and now we did a search. That's not the way I'm going to look at it. Sorry, I apologize. This is just administration only. To see the actual results, we need to go within the run. And we actually were within Bandit, so I'm going to click on that. Now we see it. The goal was to make these things where you have to delete the run or submitted file in order to delete whole objects. We can't go in here and edit things. I kind of consider that inappropriate, where we just delete things. The provenance of additional things was kind of whack. But we go on here, we see, okay, here are the Bandit findings. Here are our respective chats. And what you'll see in our user acceptance test slides and not test specifications, along with the other things, we actually see me going through the delete process and stuff. So I'm going to end it there. I'm going to go back to the view site, and I'm going to look back at the walkthrough of implementation. And again, front end rendering, user story 9. We're not doing the automated testing. That's covered in the previous part 2. And that we just went over. And the user story 15 was where this really came to head. Is we went through our search, we went through level 1, level 2, coding tasks, our search capability, and the 12 through 14 dealt with the fine-tuning notebook, which is separate. That's a developer conference. I think we would have to host with some people, and we would need a walkthrough period. It would probably be an all-day thing, if not a week, depending on your audience. So it would be getting it up and running, and then briefing each thing, and then saying, hey, well, why didn't we do this? And then you just kind of throw lettuce at Patrick on this. So I'm going to go ahead and stop it there. I appreciate your time, and await the next task, because I'm going to join all these videos together. 1. All right. Part 3 of my Python buddy. We're going to review over our project, and then at the end have a small AAR. I didn't see it in the requirements. But I'll just go over the 3 aspects of what we did well, what did not go well, and what could be improved. I did not see that in the rubric, but we're going to cover it anyway to cover our bases. So the project review. We're going to review over the accomplishments during the sprint. We're going to go over burn down charts, and we're going to go over code velocity and frequency metrics. We're going to talk about our technical difficulties, problems, and challenges in the software development process, and improvements in terms of development tools that helped us achieve better progress. So let's go to my notes. All right. The burn down chart for sprint 3. We collapsed 10 feet away from the finish line for a good part of the sprint, where I was having trouble with the fine-tuning of the notebook to the satisfactory level where it was, you run it once and then it stops, you have your stuff in Google Drive. That is the most succinct way I could put it. I had problems with hashing, I had problems with storing, I had problems with conversion because I just didn't declare my variables right. And for a minute there, I actually had like wrong versions and I wasn't using the GPU. And then I had to buy subscriptions on top of the academic collab subscription. So this sprint had a lot of problems, but we did end up with our model acceptance tests finally reported in the first week of sprint 4 and consolidated into our test specifications, where we also hot linked our results. That was, in a nutshell, what happened in sprint 3. And we still kind of stayed ahead until the very end. I did not like what I had at the end of sprint 3. So although we kept up with things and I said some stuff blended into sprint 4, I did not like, and some things popped up personally. I just did not have the stuff ready to go until the week after. I doubled down on some time. I redid a number of things, and we made it work. So that's how sprint 3 went. Sprint 4 made up for lost time. Almost had it where we crossed the ideal spectrum. And what was going on here was just integration. We did integration front end. We had most of our integration done for the notebooks, and the notebooks were mostly working off the backend API and our prompts, of which I had to revisit a couple times because I really narrowed down my prompts, because it looked like when you would, and it was kind of like a Rube Goldberg device with a whack-a-mole. And when you would put in the ability to correct to one problem, another problem came up, and I was like, you know what? You are a professional Python developer, or you are a summarizer, and then just very short words after that. And we had a good baseline that actually performed better than like a full page of prompt against this LLM. So I found that the future work for this could be a chain of thought where you would break down the user's question into pseudocode and then you program against it, all of which would be good in an effort in and of itself that's not time stamped and is in a more research laden environment instead of a Capstone where we had strict end dates. What also popped up here is finishing up our unit test, the health dashboard, and we made it work in regards to broadening our health dashboard to show, okay, what needs to run and what is possibly going wrong. So we did error handling, the health dashboard, say, hey, Redis is running, your runtime is showing up, your NVIDIA driver showing up, Llama CPP is good. And then we also had just a test to make sure that the LLM's working. We actually cached the results of the first one of the LLM, so it's not constantly pinging it. So you have a refresh every 5 seconds, and it would show the relevant software, hardware status without just completely taking up a GPU. Because you don't need to keep inferencing over and over and over again until you start popping up with the other errors, I found. And that would be production. That would not be MVP. Okay. So let me get my notes adjusted, then we're going to go to this. Coding velocity and frequency. So I missed this in demo 1, so I just explicitly did brainstorming. I was like, what could we present to show the velocity and frequency? Thus, we have some git commands we ran, and we have the results right here. So here's sprint 3. We did a total of 15 commits at 0.37 commits a day, and we had a lot of, I would say, a lot of churn, but the churn ratio, which represents, have you crossed the Rubicon in regards to, are you refactoring more, developing new capability? And from what I've been told when I had a chance to talk to some of my colleagues, they're like, what do you count as a churn ratio? And then they worked on that. 0.5 is the threshold, and it's also depending on what your boss tells you. So I was like, okay, well, let's do 0.5. Well, we didn't hit that in sprint 3. And we... according to our burn charts and our ideal, we made it work for sprint 3 pretty much in conclusion. Now for sprints 4, we did almost triple the amount of commits because I learned my lesson from sprint 3, And I was like, okay, we're going to break out the taskings, as you could see in my completion thing back in part 1. Is we averaged almost a commit a day, and it was very segregated, very isolated, very succinct. And it was like environment update, HTML update, CSS update, uh, unit test this specific one update. So we were very pinpoint and accurate in what we were doing. Thus, we actually had less of a churn ratio, even though we had quite a lot of additions and still kind of quite a lot of deletions. Now we go back to let's go back to this, and because this is just a good. Okay, so the development tools, the GitHub project was good in that it kept me organized. Um, I wish I communicated with the professor more, and I wish I was able to dedicate my full time to this. With a full time job and a kind of an infinite middle of the night, I wasn't able to do proper time management, um, but it still worked out in the end. Now, Google Colab, access to rentable 80 gig A100s helped quite a lot. Llama CPP helped with the integration the into the project itself, and Django was the front end framework that saved the day, where I basically just went through tutorials and got my application up, and it's user authenticated. AWS helped me get my MVP online, and the IDE, the pre-commits, the unit test structures, and just basic looking up stuff helped me progress through this entire thing, so that from beginning to end, I was able to snowball the effort into this MVP. Since this is turned in and I didn't see this in the rubric, I'll just quickly go over this. What went well is we established our baseline MVP. What did not go well, it was basically a sausage factory to get to that MVP. Quite a lot of lessons learned from front end, full stack development, training of an LLM, integrating an LLM, and prompting against the LLM are each their own individual task sets that could take up quite a lot more time than even this capstone or major could go into. But we had to make these things work. Now, let's see here. What could be improved upon? Time management, communication, and the ability to say no to myself in regards to getting things up and running. However, pushing myself beyond what I thought was originally capable, now we have an MVP that I'm going to build upon to help my career. So the overwhelming work that I took on will be worth it, as we are doing chatbot integrations at my work now. So I'm going to say that is in conclusion for part 3. Thank you for your time. Let's see here. Back one.